relation. We're going to do some vocab right now. A relation is a set of ordered pairs. Now, when you have a graph and I tell you to graph a point, that point is an ordered pair. Now, we can show these relations in many ways. You might see a graph. So if you see a graph and there's some points or there's some kind of line on it, that's a relation. That's just a fancy math word for calling it a graph. You might see a table of points. So like a 2-column, you've got X's and Y's. If you have a table and it's labeled X and Y, you've got a relation. You might see a mapping. If you look down at the bottom of your paper, number 3, that's a mapping. You've got like a number with an arrow. Or it can be expressed as an equation. So basically, a relation is just this big, broad term for lots of things we see in math. Equations, graphs, all of that. A function is more narrowed down. So you've got all of these graphs and tables in this big like pile. Some of those are considered a function. A function, so any of those graphs, any of those tables, when you look at the x values, if the x values do not repeat, that's the easiest way to think of it. X values do not repeat, we consider it a function. So, for example, I might make a table, and I'm going to make it a sideways table. You might not be used to that. If you don't like it sideways, you can go up and down. But I might have an x values of 2, 3, 5, and -1. Y values of 6, 4, 6, and 0. I have listed 4 different points there. I've listed the point 2, 6, the point 3, 4, 5, 6, and -1, 0. That is a function because the x's, are all of those x's different? Yeah, that's a function. What about the y's? Are all the y's different? No. That doesn't matter. The y's can be the same. They could have all been the same, and it still would have been a function. So to be considered a function, all of the x values have to be different. So I want you to make the same table, but I want you to change one thing about it to make it not a function. Who wants to tell me what you changed to make it not a function? Anybody? Get my cards out. Yes.
Is the x and y the same?
Do what now?
Is the x and y the same?
What specific numbers did you change?
2 and 6.
What did you change about them?
Made the y 2.
So if you make the y a 2, we have the same x and y value. What I'm looking for is 2 of the same x's going across. Okay, so I see what you did, but we're looking for 2 of the same x's. You changed the 5 to a -1. That would have worked. And everything else stayed the same. There's possibly one thing I'll show you that you could have done that would not have worked. So you see how here I have 2 x's that are the same. You could have done several different things. You could have made the 2 a 3 or the 3 a 2. What you could not have done was switch the 2 or the 5. Like if I would have made this a 5, those would have been identical points, 5, 6, and 5, 6. That doesn't really count because it's literally the exact same point. Okay, but most anything else you could have done. It's easiest to tell if it's a function or not a function if you have a table. When you have a graph, there's something called the vertical line test. So for example, let me draw a graph that would be a function. The vertical line test says, the vertical line goes up and down, by the way. Vertical line, you're going to take an imaginary vertical line going all the way across. If it hits that graph in more than one spot, it fails the test. So think of like a laser beam shooting up from the bottom. Everywhere I go across, my yardstick is only passing that curved line one time. If I were to turn this sideways, notice how my yardstick would cross here and there. So I'm going to draw an imaginary line. See how a vertical line crossed through more than once. If it does that in any spot on my graph, it fails the test. It's not a function. Because if I were to think of what these ordered pairs would be, this right here is like -1. So this might be the point -1, 2, -1, -3. They would have the same x value. So that makes them not a function. There are 6 examples down here. All right. You've got people around you. I want you to talk to the people around you and all you're going to do is put yes or no. Yes, it's a function, or no, it is not a function. All right, so any questions on deciding if it's a function or not? No. All right. Let's go on in our notes. Function notation. Notation, that word just means the way we write it. The way we write functions is going to look a little different than maybe what you're used to. So you're probably, if I gave you an equation, and you're probably going to see y equals. You saw that when you were graphing a line. Y equals 2x plus 7. Well, there's going to be a very slight difference in the way we write it. Instead of having a y, you're going to have this. So I want you to write it down, and then I'll tell you how we say it. So instead of y equals, you have this. And we say f of x. So it might be g of x. But that is function f. And we have an x, it says f of x because that equation has an x in it.
Why do we write it different?
Because there's things that we're going to do later on with those functions, and it is just the way you need to write it. And kind of from here on, you'll see that most of the time. This is the notation that's used more in higher level math, like above Algebra 1. You won't see it in geometry probably, but So f of x. You're going to have questions where, like for example, I say f of x equals 2x plus 7. Find f of negative 3. So negative 3 in this case is replacing what? X. So I had f of x. It's saying find f of negative 3. The number that's in parentheses, this is your x value. If it's in parentheses, it's your x. And so what we're going to do is plug that x into the equation where there's an x. So I'm going to say f of negative 3 equals 2 times negative 3 plus 7. Now we can do that without a calculator. What is 2 times negative 3? Negative 6. And then if I add 7 to that, I get 1. So f of negative 3 equals 1. If I were to graph this line, if I were to graph that line, I would see the ordered pair, the point negative 3, 1. Negative 3, 1 would be on that line. So negative 3 is the x. The number you get out is your y. So I've got 6 problems. I'm going to do a couple with you, and then I'll let you, well, we'll probably stop there and then tomorrow finish these out. So in my directions, I actually have 2 different functions. Now, if I had put y equals on both of them, you wouldn't be able to tell which one's which. But now, if it says f of, it's the first one. If it says g of, it's the second. So number 7, f of negative 9. So I'm using the one that starts with f of x. Okay. So f of negative 9 equals, I'm going to put a negative 9 in for the x. So negative 5, and then in parentheses I'm going to have a negative 9 minus 14. What is negative 5 times negative 9? 45. And then if I subtract 14 from that, what am I going to get? 31. That is correct. Now I won't expect you to always do these without a calculator, but we're almost at the end of class. Your calculators are going to be on the Chromebook, so we're not going to get those out right now. All right, we'll do number 8 together. 8 says g of 2. So what's my x value? 2. Which function am I plugging it into, the first or the second? The second, because it's g. So g of 2 equals, I have an x here and I have an x there. You're going to put the 2 in both of those spots. So I've got a 2 going there, and it's squared plus 9 times 2 minus 1. So I put my x value of 2 in all of the x's. Any questions on how I plug that in? Okay, what is 2 squared? 4. What's 9 times 2? 18. minus 1. So we have 4 plus 18 minus 1. And what does that give me? What is it? 21. Yeah. 21. We'll stop there for today.